So hello, welcome to everyone to another video. So today we'll discuss about the IIT JAM 2026 question. So we'll start from the NAT section. As you know, the response sheet is already out. So those who did not download, they can download from the JAM portal, so that you can match your answer. So we'll start from the NAT section, from NAT 1 mark question. So the first question here is given. This is the figure where a coral reef is deposited at the continental margin since 120 million years. That means you can see here coral reef, it is deposited from here to this point, to the sea level. So it takes a time of 120 million years. So which will be 120 into 10 to the power 6 year. Million year means million year ago. Then this much time they deposited up to a depth of 3000 meter as you are given here. So we have to calculate the average subsidence rate. To calculate the average subsidence rate in mm per year. That means, so the depth is given here 3000 meter. So the answer, it is asked in mm per year, so we have to convert the depth into mm. So it is 3000 into 10 to the power 3 mm. Now the average subsidence rate will be average subsidence rate will be, that is the age taken for the subsidence, that is your 120 million year, and this, the subsidence about a depth of 3000 meter. So we'll calculate 3000 into 10 to the power 3 mm per 120 into 10 to the power 6 year. So it will be 3 by 120 mm per year. It will be 0.025 mm per year. So answer, it is given, you have to round up to 3 decimal, so it will be 0.025 mm. So answer will be 0.025 mm. Let's move to another question. So given a metallic mineral weighs 44 gram. So when we are solving questions, always remember, you have to always write down what is given. So here weight of the mineral, it is given 44 gram, and when you submerge it in water, it displays 11 ml of water. So that 11 ml of water, it displays 11 ml of water displays 11 ml of water. So you know 1 ml is equal to your 1 cc, centimeter cube. So it is a unit of volume, it is also a unit of volume. So 1 ml equal to 1 cc. So 11 ml, it will be 11 cc. So now the density of the mineral, it is calculated by the weight of the mineral. In, you can say that weight, that is 44 gram, it is in air, divided by the amount of water it displays. So the density of the mineral will be there is a weight of mineral in air, you can say, and the volume of water it displays when it is fully submerged or immersed. So that will be your 11 cc. So it will be 4 gram per cc. It will be 4 gram per cc. So answer will be 4 gram per cc. Answer is also asked in integer, so it will be 4. Next, it is a very common question. They already asked many times in previous year. So given it is given the lithostatic pressure at the base of 35 kilometer continental crust. Suppose you take this much is your 35 kilometer. So we have to calculate the pressure here. So the density of the crust or average density of the crust, it is given 2.8 gram per cc. So we know formula, that is the pressure equal to rho g h. H you can say here depth. Rho is your density, g is your acceleration due to gravity. So first the answer is asked in Pascal. So you have to convert all these unit into SI unit. So your depth for h you can say it is given 35 kilometer, which you have to convert in meter, that is 35,000 meter. Then rho it is given 2.8 gram per cc, so we have to convert it into kg per meter cube, which will be 2800 kg per meter cube. Then acceleration due to gravity, we have to take 9.8 meter per second square, that is g is given 9.8 meter per second square. It is already in SI unit, don't have to convert it. So then we'll put the formula, that is your 35,000 into 2800 into 9.8. The answer will be in Pascal. Answer will be in Pascal, the unit of pressure. Now we have 35 into 28 into 9.8 into 10 to the power 5 pascals. But answer, it is asked in 10 to the power 8 pascal. So it will be, shall calculate this. So 9604 into 10 to the power 5 pascal. So if you convert it to 10 to the 8, it will be 9.604 into 10 to the power 8 pascal. So answer it is, we have to round off up to 1 decimal. So after 1 decimal it is 0, so it will remain 9.6. It will remain 9.6. So answer will be 9.6. Then a Clinopyroxene crystal in basalt measured to have a composition of Mg 1.2, Fe 0.4, Ca 0.4 and Si2O6. So we have to calculate the Mg number or Mg fraction in percentage. So the Mg fraction, it is not affected by this Si2O6. So only consider this. This place is add up to 2. You know the general formula of pyroxene, that is, we can say X2 Si2O6. So next comes to another question. We are given a Clinopyroxene crystal in basalt measured to have a composition of Mg 1.2, Fe 0.4, Ca 0.4, Si2O6. So we have to calculate the Mg number. That is, what is the percentage of Mg fraction? So the Mg member that contribute to this place, it is not affected by these Si2O6. So this type of numerical always asked in IIT JAM. So here we have to calculate the percentage of Mg. So it will be, this place will add up to 2. It will be 1.2 divided by 2 into 100. It will be 75%. Will be 75%. So answer will be 75%. So it is asked in integer. will be 75%. So let's move to another question, that is sphalerite. It shows limited isomorphism. So question is given, sphalerite show limited isomorphism. Consider a colorless sphalerite having 33% S and 67% Zn. So what is the formula of sphalerite? It is ZnS. Zinc sulfide, it is sphalerite. It is an ore of zinc. So this Zn place, it is occupied by 50% of Fe. So we can write down the formula like this: Zn 1 minus x, Fe x, then your S. So the ratio of atomic proportion of Zn to Fe. So here atomic number is given, so we can calculate their fraction within Zn, within you can say sphalerite, that is what is the fraction of Zn, what is the fraction of S. But the simpler way you can calculate this, like Fe it is 15%. If Fe occupy 15% of this place, then Zn will occupy 85%. Zn will occupy 85%. So now we have to calculate the proportion, that is ratio of atomic proportion of Zn to Fe. So simple, we will take the ratio, that is 85 by 15. Base 85 by 15, that will give you the ratio of Zn to Fe. So it will be 85 divided by 15. It will be 5.66. So we have to round up to one decimal. So in second place we have 6. We can write down 5.7. So the answer will be 5.7. So you don't require to use these things. So it's the simplest way you can calculate in this way, which will be easier and faster. So next, come to another question. So this is a new type of question, but it is not that tricky one. Here we have given the subsidence at a horizontal distance of x from the central line. So this is a central line. Okay. So the subsidence x from the central line of a cylindrical tunnel is given s equal to s max into exponential minus x square by 0.5 into h square. That means it is e to the power. Okay, this e to the power. So I have given s equal to s max into exponential of minus x square divided by 0.5 h square. This is given. So the h, it is given your 50 meter. So we have to calculate the ratio of surface of subsidence at x equal to 10 meter and x equal to 20 meter. So first we will calculate what is that the ratio of surface of subsidence, that is at s 10, it will be s max, the exponential of, so the value of x is 10, that is minus 10 square divided by 0.5 into h is given 50 square. So it will be s10 equal to s max exponential of minus, it will be 100, it will be 1250. Then we have to calculate at x equal to 20. So s20 will be s max into exponential of, it will be minus 20 square, because x is 20, so it will be minus 400 divided by 1250. Now we have to calculate the ratio of surface of subsidence at x equal to 10 to that of x equal to 20. Means we will take s10 divided by s20. So it will be s max. So this will be cancelled each other. Then we can write down, so they will, there will be division. So it will be exponential minus 100 divided by 1250 minus of 400 divided by 1250. So it will be exponential of 300 divided by 1250. You can write down e to the power 0.24. It will be 0.24. Will be 1.27. 1.27. So you have to round up to one decimal place. So it will be 1.3. It will be 1.3. So the answer will be 1.3. It will be 1.3. So next come to another question. It is also a very easy question. So one mole of parent nuclei is undergoing radioactivity decay. So the fraction of atoms of this nuclei that has decayed after 3 half-lives. So it is asked how much is decayed. How much is decayed? So you know one formula, that is half to the power n equal to fraction of substance remain after decay. So n is your number of half lives. So n is given here 3. So half to the power 3. That is 0.125 fraction will remain. That is 0.125 fraction will remain. So how much is decayed? That is 1 minus 0.125. That is 0.875 fraction has already been decayed. So answer will be 0.875. So I have to count out to 3 decimals. So it will be this much. So come to next question. So the true dip amount of a normal limb associated with an asymmetrical folding is 20 degree. So we have a asymmetrical fold, suppose like this. So we'll draw like this. So this is suppose the limb. So it has a dip of 20 degree. A dip of 20 degree. And the angle that this limb makes with the axial planar cleavage. So suppose we have an axial planar cleavage, this one. So limb will make angle of 35 degree. Limb will make angle of 35 degree with this. This is your axial plane cleavage, and this is your limb. So we have to calculate the true dip of the axial planar cleavage. So what is true dip? This is the angle of inclination from the horizontal. So this is our horizontal. So now this angle will be the true dip of the axial plane cleavage. So it will be 20 plus 35 will be 55. So the answer will be 55 degree. Next, another question. This is from the hydrology question, that is from Darcy law. So an aquifer with hydraulic conductivity of 60 meter per day. So hydraulic conductivity is given, that is your K. It is given 60 meter per day. It experiences a head loss of 20 meter. So head loss is your del H, that is 20 meter over a distance or length of 1000 meter, that is L is given 1000 meter. So we have to calculate the flow of water per unit area. That means A is given here 1 meter square you can take. So we have to calculate the flow of water, that means discharge per unit area in milliliter per minute. So the flow of water per unit area, we know that is Darcian velocity, or you can say specific distance, that is Q. So we know one formula, Q equal to K I. So I you can write down del H by L. So K is given 60, it is in meter per day. Del H is given 20 meter, that also in meter. So it will be 20 divided by 1000. So it will be 1.2 meter per day. It will be 1.2 meter per day. But the question, it is asked in millimeter per minute, you have to calculate. So we just convert this meter per day into millimeter per minute. So it will be 1.2 into, if you convert meter to millimeter, it will be 10 to the power 3. It will be 10 to the power 3 millimeter divided by, so if you convert day into minute, so it will be 1440 minute. 1440 minute. So if you calculate this, it will be 0.833. If you round up it to 2 decimal, it will be 0.83 millimeter per minute. It will be 0.83 millimeter per minute. So answer will be 0.83 millimeter per minute. So come to next question, where a hypothetical mineral has a formula of X7 Si8 O20 OH whole 2. So this looks similar to amphibole formula, that we know X is a divalent cation, but we'll calculate here. So this is a neutral compound, all the charge will be add up to 0. Now suppose we'll take the charge of X as C, suppose 7 into C plus silicon, it has 4 plus valency, that is 8 into 4, that is 32. Then oxygen has -2 valency, that will be 22 into -2, it will be -44. Minus OH has valency -1, it will be -2, which will add up to 0. 7 into C, this will be your, it will be -14, it will be -14, it will be 0, then C will be 2. So answer will be 2. So the valency of X cation will be 2. So next comes to another type of problem. So this is your Dale value calculation problem, where we will calculate the Dale value, that is the Chor value E N D. It is, you can say, sample value divided by standard value minus 1 into 10 to the power 4. This is the formula. So first we have to calculate the value of sample, then we will calculate the value of standard. So here, which one is the sample? That is your pyroxenite. So I have to calculate the pyroxenite sample value, that is the initial value of the pyroxenite at 1 billion year. Then standard here your Chor, that is chondritic uniform reservoir, that is taken as a standard value during your SMND calculation, SMND age calculation, or SMND radioactivity calculation. So then we will calculate the initial value of Chor for 1 billion year, then we will put the value of sample standard, we will get your answer. For that we have to use another formula, that is your isochrone formula, that is, let me recall the formula, Nd 143 divided by Nd 144 value at present age is equal to Nd 143 divided by Nd 144 during initial, or you can say before decay, plus Sm 147 divided by Nd 144, that is the value of parent, e to the power lambda t minus 1, will be e to the power lambda t minus 1. So here the value we'll calculate the value, initial value, both for pyroxenite, that is for the sample, and for the char or for the chondrite. And we'll take the age as 1 billion year. So first we'll calculate the e to the lambda t minus 1 value, so it will be easier for rest of the calculation. So lambda is given your 6.54 into 10 to the minus 12 year inverse. So it will be e to the power lambda t minus 1. This e to the power lambda is given 6.54 into 10 to the power minus 12 year inverse into t is 1 billion year, that is 10 to the power 9 minus 1. So it will be 0.00654 e to the power this much 1. It will be 0.00656. So the value of your e to the power lambda t minus 1 is your 0.00656. So now we'll calculate the value of ND 143 by ND 144. ND 143 by ND 144 at initial time or before decay for pyroxenite. So for pyroxenite, ND 143, 144 measured, that is 0.512838, it is at the present time. So this is given 0.512838. This we have to calculate. Then this is given 0.21, and we already calculated the e to the lambda t minus 1 equal to 0.00656. So the value of present is given 0.512838. We have to calculate ND 143 divided by ND 144 at present for, we'll say, pyroxene, plus 0.21 into 0.00656, which is the value of e to the power lambda t minus 1. So ND 143 divided by ND 144 V for pyroxene, that is the value of sample, will be 0.512838 minus 0.21 into 0.00656. So let's calculate what will be the value. So it will be 0.5114606. 0.5114606. This is the value of pyroxene at present days for 1 billion year. So then we'll calculate the initial value of ND 143 by 144 for char, or you can say chondrite. So present value it is given ND 144 by 143, the present value, 143 by 44 is given 0.512638, this is the present value. So we have to calculate the initial value, 143 divided by ND, that is our initial value, of quadratic uniform reservoir with 0.1967 into 0.00656. So the value of, you can say, ND 143 divided by ND 144 initial value or chondrites, it will be, to calculate this, it will be 0.51152816. So now this is your standard value. Now we have both initial value of pyroxene, the initial value of Nd143, Nd144 of pyroxene and chondrite. Now we'll apply the formula. So END will be sample by standard minus 1 into 10 to the power 4. So sample, it is 0.5114606 divided by standard is 0.511528162 minus 1 into 100, sorry, into 10 to the power 4. So this value will be 1.00228, sorry, 22089 minus 1 into 10 to the power 4. So it will be 0.0022089 10 to the power 4, which will be 2.2. To be 2.2. So the value of E and U will be 2.2. So this is a lengthy problem. So here you have to calculate the deviation of or del value of Nd143, Nd144 in the sample relative to chondrite. So the sample is here your pyroxene and chondrite, here it is given Chor value. So first we have to calculate the initial value of Nd143, 144 for 1 billion year. Then we have to calculate the chondrite value of initial value of Nd143, 144 for chondrite. Then the chondrite value will be considered the standard value and pyroxene value will be considered as your sample value. So sample by standard minus 1 into 10 to the 4, or you can say sample minus standard divided by standard into 10 to the power 4. So answer will be 2.2. So let's another problem. Based on the anorthite content of fast form plagioclase crystal from a liquid composition of 50% mole anorthite. So we have a liquid that has So we have a liquid that has 50 mole percentage of anorthite. So you just draw a vertical line from the 50% to till it touches the liquidous curve. So this is the liquidous curve. Then draw a horizontal line towards the toward the solidus. So it will touch here. So this will be the solid percentage of, that is plagioclase, that form for this liquid composition. So liquid composition is 50% anorthite, 50% albite. So it will produce an anorthite of, so here anorthite percentage is here 85% and albite percentage is 15%. So based on the anorthite content, the fast form plagioclase crystal from a liquid composition of having 50% mole anorthite is dash mole percentage. So here anorthitic content of the solid is asked, so it will be 85%. Answer will be 85%. Another question, where 4 vertical boreholes are drilled on a flat topography at 50-meter interval along the east-west direction. So this is our surface. So we have to put borehole. Suppose we have to put 4 boreholes. 2, 3, 4. All are separated by 50-meter distance. Then the borehole intersect the coal seam at a depth of 100 meter, 130 meter, 160 meter and 190 meter. So suppose this is our coal seam. These are coal seam. This is your coal seam. So when we will put the borehole, suppose for one place it intersect at a depth of 100 meter. For 2 place it intersect at a depth of 130 meter. For 3 places it intersect at a depth of 160 meter, and for 4 places it intersect at a depth of 190 meter. So you have to calculate the true depth of the coal seam. So how we will calculate the true depth? So we have a formula of depth, that is tan of, can say depth, that is vertical drop by horizontal distance. So you can say from 1 to 2 place, the distance is 50 meter, and this place is at a height of 100 meter, this is 130 meter, so this will be 30 meter, that is the vertical drop. So now we can calculate tan theta equal to 30 by 50. So it will be theta equal to tan inverse, it will be 30.963. So I have to round up to 2 decimals, so answer will be 30.96 degree. This will be the true depth of the coal seam. So in these type of questions, see, there are extra data, so it is only given to confuse you, so that you can try to solve it in various other way. But it is just, if you know the concept, then you can easily solve in one step. Then question from your porosity. So sandstone sample with 100% quartz, that means it is consists of completely quartz. That 100% data is not required or will be used in calculation. It is simple given to confuse you. That means a rock completely consists of quartz. It may be your highly matured sandstone. So it has a porosity of 30%. So porosity is given 30%. Then density of the quartz, that is density of the mineral, it is given 2.65 gram per cc. So we have to calculate the bulk density of the sample. That is, we have to calculate the rho b. So the formula is porosity equal to 1 minus bulk density by particle density into 100. So now porosity is given 0.30, you can say 0.3. Rho 1 minus rho b we have to calculate. Rho b we have to calculate. Rho m is given 2.65. So it will be bulk density by 2.65 into equal to 0.7. So rho b will be 0.7 into 2.65. 0.7 into 2.65, it will be 1.85. 1.85. So we have to round up to 1 decimal. So after it there is 5, so it will be 1.9. So the bulk density of the sandstone, it will be 1.9. Then this figure shows the seafloor activity with depth in sedimentary core from a lake, where the sedimentation rate was uniform. So in this type of question, it is from your rate of sedimentation. So you just, in this case, we have to just find out the depth. Always the deposition or erosion always given, it is always occur in a uniform rate. So just find out the depth and time. So then you can easily calculate the rate of sediment, which is always in time by depth by time. So here the maximum seafloor activity marking the signature of the bomb cavern was measured at a depth of 45 centimeter. So this much depth is given 45 centimeters. So there are also other depths are given, 40 they given, 20 given, then 60 given, but the maximum activity age is given, that is 1965. So this is your 1965. Now at zero depth, or that is 2010. So the difference age is 45 years. and depth is 45 centimeter. So rate of sedimentation is asked in mm per year. So 45 centimeter it will be 450 mm. So now the rate of sedimentation will be for 450 mm divided by 45, it will be 10 mm per year. So answer will be 10 mm per year. So it's a very easy question. So this type of question will commonly found in IIT JAM exam. Then this is also a very common question. So if you solve the PYQ section, then you encounter this type of problem. So that is, it is from your Aries hypothesis, that is isostasy. So you have crust and mantle, and from this diagram you can see the crust has a similar density. All the crustal part has similar density, but they have different thickness. So that refers to an Aries hypothesis. So this is the mountain, it is given, height is given 5 kilometer. So the density of the crust is given 2700, that is kg per meter cube, and the density of the mantle it is given 3300 kg per meter cube. So we'll apply the Aries hypothesis, and that will be the root will be here, root will be h. Usually we take that 5 kilometer as h, but here it is asked h. That will be your root thickness. It will be 2700 into 5 kilometer divided by 3300 minus 2700. So the kg per meter cube will be cancelled. Only the answer will be in kilometer. So it will be 2700 divided by, it will be 600 into 5. So it will be 22.5 kilometers. So answer, it is round up to one decimal, it will be 22.5. Also unit is asked in kilometer, so it will be 22.5 kilometer. This question also is from previous year question, a similar type of question already asked. So in a mineralized torolite garnet biotite schist, the estimated metasomatic sulfide mineralization is 4%. Suppose we have an ore here. See, this is an ore. So from which you can say, suppose this is your 4%. This is your 4%. This 4% is your sulfide ore. Sulfide ore. This 4% it consists of 30% chalcopyrite, 30% chalcopyrite, that is CuFeS2, then 20% pyrite, that is your FeS2, then rest being magnetite. The rest being magnetite. So we have to calculate the maximum grade of copper, that will be in gram per ton. So this, from this 4% of sulfide, only this chalcopyrite contribute copper. These two does not contribute copper, so we will not calculate these two. So we will, the only copper present in FeS2, chalcopyrite. So that is, we have 30% of copper, 30% of chalcopyrite in the sulfide ore. So first we will see how much copper, or what is the fraction of copper present in chalcopyrite. So first we will calculate the weight of chalcopyrite. So in this type of problem, we have to remember this formula. So it will be your Cu is given 63.55 plus Fe is given 55.85 plus 2 into 32.06. Will be 183.5. So the fraction of copper present, fraction of copper in chalcopyrite will be the weight of the copper by total weight, that is 63.55 divided by 183.5. It will be 0. Approximately 34, 0.34. 0.3463. This much of copper present in a chalcopyrite. When we have only chalcopyrite, that means we have only 100% of chalcopyrite. From that, 34% will be copper. 34.63% will be copper when we have 100% chalcopyrite. Here in this deposition we have 4% sulfide ore, from which 30% is your copper sulfide. 30% of your chalcopyrite. Then what will be the fraction of chalcopyrite in the whole ore? That will be your 0.30 into 0.04. It will be 0.30, 0.012 with 0.012. So see why we will calculating this? Because we have 4% of mineralized from the whole metasomatic deposition or whole deposition. 4% is your only sulfide. From that 4%, 30% is your copper, 30% is your chalcopyrite. So then what will be the fraction of the chalcopyrite from the whole deposition? That will be your 0.012. So we have to calculate the grade from the whole deposit. So now 0.012 fraction is your copper chalcopyrite present in the whole deposition. Then how much fraction of copper will be present? In 100% we have 0. Or you can say from 100% of chalcopyrite we have 34% approximately copper present. So this is your 1.2%. From the whole deposit, 1.2% is your chalcopyrite. If 100% chalcopyrite contains 0.34%, 34 approximately percentage of copper, then how much 1.2% of chalcopyrite will contain? So the percentage of copper in the whole rock, it will be your 0.3463 into 0.012. It will be 0.0041556 fraction of copper present. From the whole deposit, 0.0041556 fraction of copper is present. Now this is, can say, the grade. 0.04% is the grade. So it is asked in how much gram you will get in 1000 kg. That means gram per ton means is how much gram how much gram of copper is present in 1 ton. So 1 ton is 1000 kg. So 1000 kg into 0.0041556. It will be 4.1556 kg. So which will be 4155.6 gram. So this much is present, 41556 gram present per ton. So from the we have calculated from the whole deposit this much fraction copper present. So what is that fraction? From 1000 kg, because it is asked in gram per ton. So it will be 4155.6 gram present per ton of the deposit. So the deposit here given, that is tauolite, garnet, biotite, schist. This in this deposition, in every 1000 kg or in every 1 ton, you will get 4155.6 gram of copper. That is the grade. That is gram per ton. So answer will be 4155.6. So it is given ki you have to round up to nearest integer. It will be 4156. So next comes to another question. The figure shows variation in optical properties of plagioclase feldspar with a composition. A feldspar from lunar anorthite with an anorthite percentage of 85%. So the anorthite percentage is given 85. So the anorthite mole percentage is given 85. So this will be your 85% of anorthite. Okay. So what will be the birefringence? So this is given your the refractive index of anorthite of different percentage. So n alpha is the lowest and n gamma is the highest. So you have to just find out what will be the value of n alpha at anorthite 85% and what will be the value of n gamma at 85%. So n gamma, it is clearly you can say is 1.580 n gamma, and n alpha it is in between 560 and 570. So we'll take that as 1.565. So birefringence will be 1.580 minus 1.565 to 0.015. It will be 0.015. Next, another very easy question for 2 marks. So it is given in the isometric system, the difference in the number of symmetry planes in class 4 bar 3m. So in case of your isometric system, we write down 3, 4, 6 to calculate the number of symmetry. So here we have 4 number of 4 bar inversion symmetry, 4 axis of 3-fold symmetry and 6 mirror planes. So here we have 6 mirror planes. Here in diploidal class 2 by m 3 bar, can write down 3, 4. So we have 3 mirror planes. So it will be 3. So the difference will be 3. So next question, consider a perfect geocentric axial dipole model of geomagnetic field at a latitude. So latitude it is lambda, it is given 30 degree north. The inclination of a freely suspended magnetic needle. So we have to calculate the inclination of the needle. So there is a formula for that. That is tan I, that is inclination, equal to 2 tan lambda. So 2 into tan 30. So 1.547. Sorry, 1.1547. We'll take 1.155. We'll take. Then I will be tan inverse 1.155. 49.11. So you have to round up to nearest integer. So it will be 49. It will be 49 degree. So this is your solution for all the numerical part. So in the next video, we'll do the MSQ section. Uh, there will be one video for MSQ, one video for MCQ, and we'll also publish the whole answer sheet in our website. So you can visit our website to get the solution or to get the answer sheet.